Hi everybody, I'm going to take you through how to do the energy skate park analysis. Okay, so this is the file. Please make sure that you fill out that heading in case your instructor has you submit this for a grade. Okay, so you're supposed to compute your mass in kilograms by taking your weight in pounds and dividing by 2.2. Okay, so just to keep this simple, all right, 100 kilograms. All right, now on my track from my skate park, so remember your skate park's supposed to look something like this, all right, where those point A's were the high points of the track. Okay, point B's was supposed to be the bottom. Okay, and then point C was supposed to be somewhere in the middle. Okay, so something like that, and I'm not really sure. It doesn't look like my loop quite hits C, so I just have 2 point C's, which is fine. Okay, so I'm going to go with 13 meters. All right, which that would make my height at point C 6.5 or half that height. Okay, but of course everybody's got their own, so this is just sample. Okay, so this is sample, so use yours. Okay, in your analysis. So the point is I'm supposed to show you how to do this. Okay, so if you can compute potential energy for question number 1 at point A, potential energy is equal to mgh. So first I write my equation. Okay, so then you're going to take your mass, all right, times acceleration of gravity, whether you use 10 or 9.8, honestly, doesn't make any difference. Okay, times your track height, okay, units of kilograms and meters, and like, use your mass. Okay, use your point A height. All right, so I was 100 kilograms. All right, and my point A height was 13 meters. So I've got 13 times 1,000, so my potential energy would be 13,000 joules. Okay, so as far as like scoring would go, all right, we'd have points for equation, points for substitution. Okay, and then points for answer. All right, and then additional points for the units. All right. Number 2, what's the kinetic energy at point A? Remember that the skater has a velocity of 0 meters per second at this point. Okay, so if we were going to do this calculation-wise, so kinetic energy is equal to 1/2 mv squared. Okay, and again, you want to use your mass in kilograms. Honestly, it doesn't matter what your mass is here. All right, because if the velocity is 0, that means that the kinetic energy is going to be 0 as well. Okay, so just like before, there'd be points for equation, okay, for putting in your numbers, okay, for getting to your answer, and then, of course, for having units. Okay, now you could also make an argument with words as opposed to equations in mathematics. So, like, if you were going to formulate that argument, okay, what you want to say is that the skater is not moving. Kinetic energy is energy of motion. No motion, no KE. Hence, kinetic energy is equal to 0 joules. Okay, so you still have to have points for formulating your argument. So think like the argument would be equivalent to kind of 1 and 2. All right, then you've got your answer. Energy is a value with units, so do you put that value with units? Don't just say 0, it's 0 joules, okay? So you can justify it that way as well. All right, moving right along. Okay, what is the potential energy of the skater at point B? So just to kind of zoom back up here, okay, in the lab you were told specifically, okay, to put your point B at a height of 0 meters, so have your track touch the ground. Okay, so using that criteria, okay, so we say potential energy is mgh. Okay, so you're going to want to use your mass. All right, gravity, doesn't matter if you use 10 or 9.8. Okay, and at point B, everyone's going to have that same height of 0 meters. So at point B, our potential energy is going to be 0 meters. Okay, as far as scoring goes, one for equation. You're going to have to substitute in. Okay, correctly calculate. Okay, and then, of course, units. Okay, I'm hoping that if you're watching this, you're kind of seeing the theme here. Now, this is another one where we could justify it, okay, with words to make an argument. Okay, so a skater has no height at B. Potential energy is energy of height. No height. No PE. No potential energy. All right? So potential energy is equal to 0 joules. Okay, and so again, this would be kind of like 1 and 2. Okay, 3 would be your answer. Okay, and then 4, don't forget, units, 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 units. All right? Number 4, okay, what is the kinetic energy of the skater at point B? So conservation, of course, that's conservation of energy. All right, so when we apply conservation of energy, okay, it just says that our total energy has got to remain constant at all times. All right, and our total energy is comprised of potential and kinetic energy. So we've done analysis for both potential and kinetic energy at point A, so we're going to use that, okay, for point B. So I want you to think like the potential energy at A plus the kinetic energy at A, that's your total at A. That's going to be equal to your potential energy at B plus your kinetic energy at B. All right, and so if we sub in for what we know at point A, okay, I found that it was 13,000 joules. So sub in whatever you found at point A. Okay, so use your potential energy. All right, for everybody, the kinetic energy at A is 0 because the skater starts from rest. All right. At B, the skater has no potential energy. That's the same for everybody because the track touches the ground. Okay, and so really all we have left here is we've got one equation with one unknown, which is 13,000 plus 0 is equal to 0 plus kinetic energy. Hey, guess what, guys? Kinetic energy is 13,000 joules. All right. So now notice I've got my equation, I've got my substitution, I've got my answer, and of course, I've got my units. All right. Could I justify this with words instead of equations and math? Yeah, sure. No problem. Okay, I'm going to make myself a little bit more space here, so I'm just going to slide this over. So bear with me here for just a second. There we go. Oh, and I forgot to write units here. Okay, so if I was going to write this mathematically, okay, to the law of conservation of energy. Okay, you need to write that out just to run it out of space. Okay. All the potential energy at A becomes kinetic energy at B because the potential energy at B is equal to 0 joules and the kinetic energy at A is equal to 0 joules. So, potential energy at A is the kinetic energy at B, and that's that 13,000 joules. Okay, oops, sorry. Running out of space here. Get that little J in there. There we go. Okay, so that's one way you could justify it. Okay, explain your reasoning. All right. All right, 5, what's the velocity of the skater at point B? Okay, so the key is that we have the kinetic energy now. All right, so the kinetic energy is equal to 1/2 mv squared. All All right, hopefully you've seen this before in your class. If not, okay, your instructor might require you to show the algebra to get to this, so I'll leave that for you, but you can take and you can manipulate the kinetic energy equation to solve for velocity, all right? So we've got our original equation, we've got our manipulated equation. Okay, so we'd have to show your algebra in there. Okay, and so now we're going to sub in our numbers. So it'll be a little extra points on this because of this extra algebra step. Okay, so you take 2 times your kinetic energy, 13,000 joules. Okay, divided by your mass, all right, which for me was 100 kilograms. All right, so you want to use your KE and use your mass. All right, but you can take and close your parentheses there. So 2 times 13,000 divided by 100 rooted. Okay, so I get a velocity of 16.125 meters per second. Okay. And then, of course, don't forget, always units. Okay. So again, this would be a point, the number 5 on this would be more points than the previous because of that extra manipulation to get the velocity. Okay. All right. So number 6, the total energy of the skater at point C. Okay. So this total energy, oops, change my, keep consistent here. Okay, well, the answer is it's going to be 13,000 joules because the total energy at C is equal to the total energy at A is equal to the total energy at B, and so on and so forth. All these values are exactly the same thing. Okay, it's 13,000 joules. Okay, and the justification, conservation of energy, means the total energy remains constant at all points on the track. Okay, so you would need to have your justification with some kind of explanation to get yourself an answer. And then, of course, don't forget your units. All right. Number 7, what's the potential energy at point C? Okay, so potential energy is mgh. All right, so you're going to take, don't forget, you're going to use your mass. Okay, don't care if you use 9.8 or 10 for gravity. All right, and for point C, I had 6.5 meters. Okay, so I'm going to use your height at C. All right. So put it all together. All right, and I get 6,500 joules. All right, so 1 for potential energy equation. All right, sub in your numbers, get your answer, and then, yep, you got it. Units. All right, number 8, what's the kinetic energy at point C? Okay, so this is where we're going to apply conservation. Okay, so that total energy at C is just equal to the potential energy at C plus the kinetic energy at C. Okay, we know that the total energy at C is that 13,000 joules. We've answered that question from conservation. So 13,000 joules is equal to the potential energy at point C, which we solved in question 7. All right, which is 6,500 joules plus the kinetic energy at C. All right, so then I'm just going to take, and yes, I do in fact need to show my work here. All right, and so I wind up with 6,500 joules is equal to the kinetic energy at C. All right, so we've got our equation, we've got our substitution, We showed our algebra, got our answer. Okay, and then, you guessed it, units. Okay, and then last but not least, what's the velocity of the skater to point C? All right, so we've kind of been through this, but this kinetic energy, which is defined as 1/2 mv squared. Okay, we can manipulate it. All right, and again, the algebra is on you. You're welcome to sub in numbers and do the algebra as well, but I think if you're organized and you have good notes, okay, you should be rewarded. So 2 times 6,500 joules divided by your mass. Okay. Also for these, before I throw this into my calculator, just a reminder, use your total energy, use your potential energy at C. All right, so same thing here. Use your kinetic energy, use your mass. Sorry for the handwriting. I promise that it says your. Here, I'll try to write it a little bit neater than that. Use your, okay. So anyways, so we go to calculator. All right. Okay, and I get 11.402 meters per second. So kind of like our, oops. Hey, what happened there? Kind of like our previous case. Okay, we start with our kinetic energy equation, show the manipulation, get the numbers in, get your answer, and then last but not least, units, okay? Just as a way to do a quick mental check, if you compare how fast your skater's going at point C, you should see that that value is going to be something less than what you found at point B. So I found 16.125 at point B and 11.402 meters, that should say meters per second, sorry, at point C. Okay, if we think about this conceptually, okay, as the skater moves from A to C, they speed up. From C to B, they continue to speed up. So we would expect them to be moving faster at B than C. Okay, as the skater moves from point B back up to point C, they start slowing down, and then back up to point A is when they stop. All right, so hopefully this is useful to you. Again, don't forget to fill out the heading. All right, and good luck on your upcoming exam. Bye, guys.